There are too many high-skilled students coming into the applied ML and data science fields, and mainly it's because of the hype that surrounds it. Whether you're in school, looking for a job, or feeling like you're lagging behind in your current role, here are 4 tips that you can use to really stand out amongst the sea of candidates that are here. I'm specifically covering things that aren't in most ML blog posts today, so nothing to do with the degrees that you need, the Kaggle competitions to win, the tutorials to follow, or the courses that you need to take. All those do great if you are looking to do ML research, but when you're thinking about application, you really need to direct your focus elsewhere. Recently, there have been multiple instances of students and engineers reaching out to forums and groups because they are worried about their future in the ML space. And I think their feelings are more than justified for 3 reasons. The first of which is that ML has taken a backseat since the whole COVID-19 pandemic. Employers are thinking that ML is more researchy than applied or essential, and they want to scale it back a bit. The second thing is that many employers who are still hiring, they are looking for people, or they don't really know what to look for in people, right? They look for people who are proficient in literally every data science skill imaginable, when all they really need is probably someone to run a sklearn regression function and be more than satisfied. The third thing is that even if there are good job postings, good employers that are hiring, it seems like there is a flood of degree-holding students that are just coming into the field whose resumes look essentially identical to each other. And that's because of all the Kaggle competitions that are out there that are popular tutorials, and everyone now has like a master's degree in CS focused on ML anyway, right? So over the last year or so, I've been doing deep research into what makes someone in the applied machine learning realm really stand out amongst the others. I've been taking notes from books, conferences, YouTube videos, research papers, forums, and all that. And I have 3 major points to share that I think will separate you from the competition. Keep in mind that these points assume that you already have some foundation, not too much, but some foundational knowledge, and are mainly looking for a leg up. The first key point is data engineering, and many ML engineers would tell you that choosing and fitting the right algorithm or model really isn't that much of your day-to-day task. It's around like 10% of your overall tasks usually, and depending on your specific job scope, you're usually doing data cleaning or data formatting, or doing the other side, doing the infrastructure on making sure the system can get the data, making sure you can present it and utilize it within an application. So it's extremely important to know common software engineering tools such as version control with Git, containerization with Docker and Kubernetes, continuous integration, continuous deployment, unit testing, and so on. But for ML specifically, it's also very important to understand database management, cloud computing platforms like AWS and Google Cloud, stream processing platforms as well like Kafka and Spark. So I know it sounds like a lot, but understanding the basics at least of these processes will really help you stand out, because this is what an ML engineer really does day to day, right? And these skills also will be really transferable when the ML hype eventually dies down. Even at my very traditional aerospace company, we're taking things like DevSecOps and open source software tools very seriously. Moving on to tip number 2. When I was doing my search, I thought that all ML practitioners were meant to be generalists, so we can apply any of our super cool algorithms to any problem agnostic of their field, right? And I thought that even if they specialize, they'd be specialized in something like NLP or computer vision. Although that might be the way to go if you're into research, you need to really dig down into one specific topic. But if you're in application, it's much more important to know your domain, know your non-technical field, right? And there are so many strong and important fields to stick to as well, right? Like medicine, cybersecurity, finance, games, whatever you fancy outside of ML. With domain knowledge and domain expertise in that non-technical domain, there's so much more that's opened up to you with that foundational ML knowledge that you have, right? So you know what data is important, you know how they can be feasibly be collected, you know how to speak the client's language, you know the client's needs and wants within that space, you know how to measure the problem, you know what metrics to apply, you also know the ML limitations when it comes to the problem at hand. The last thing is that you know what features are crucial to the problem that you're trying to solve. All right, so, and the thing about, the non-technical domains is that each domain could be so deep that you need a lifetime's worth of experience to really understand the problem space in the first place, right? Let's take a recent bot classification example that we worked on. Okay, bots are a big problem, and we knew that, right? But thinking about how to properly build a system to identify these bots required so much more digging and domain knowledge that we really didn't expect in the first place, right? So it's who built these bots? How are these bots built? How can you distinguish between a suicide bot and a generalist bot? What is Jagex currently doing? What data can we collect without Jagex knowing and banning us? And it gets even more into like philosophical and economical questions as well. So like, is it really worth trying to ban bots in the first place? And the list goes on. So in essence, it takes time. It takes time to understand these domains. And now all that was for one specific problem within one specific game. And we required so much digging that by the time we were done, we were opened up to so many different problems within this sphere and so many things that we could solve with ML within this domain. So just imagine the kind of things that you could tackle if you really understood the domain in the first place, right? Understanding the domain leads you to all the problems that you could solve, and understanding all the problems leads you to all the ML applications that you could further elaborate on. And it takes time to understand, but once you are there, you are literally at the top of your domain because no one else has applied ML in that way before, right? In that non-technical domain, and that's leaving so much room for opportunity. Moving on to the third tip, even the best of models fail in unexpected ways during deployment. And it's the same with many software engineering tasks, right? When you put something out into the real world, it fails in ways you could never have imagined. But there are some seriously particular considerations when you're thinking about ML in deployment. And this could be already a whole video series, but I'd suggest you take a look at the book by Emmanuel M. Mason called Building ML-Powered Apps, where he goes over that in very much detail and how to, take care of that. But here are the 4 things that he really mentions to keep in mind, right? The first is data and model concerns. So how do you know if your data is biased? What happens if your data is biased, and who owns the data in the first place? Modeling concerns like feedback loops, would that really damage your model? And abuse, how can people really, abuse your model? The second thing is you have to take into consideration the deployment environment choices. So is your model on the server side? Is it on the client side? Is it going to be a hybrid of both with federated learning, where each user has their own model? The third thing is building safeguards for your model. He goes over how to do that, I think, really well. But there are things that you need to do. So like engineering around failures, either failures of input or failures of your model itself. There's also things like data processing, making sure your data is, consistently always the same, even if something changes on that very, very back end. Making sure that your data isn't manipulated in the wrong way over time. Lastly, he talks about how to monitor your models, right? Making sure that you monitor for monitor the refresh rate or the abuse on the model's system. You also really want to choose what to monitor. So whether you monitor model performance or business metrics is completely up to you, depending on what your problem is. And then also practice for CI/CD in ML, also known as ML ops, using A/B testing and other methods. My main takeaway from this is that we need to deploy our projects more often. ML side projects are now typically just, taking clean data sets, processing it for a little bit, doing something with the model, and then showing the results and leaving it at that, right? It leads to so many ad hoc projects that are firstly never going anywhere after that, but also we miss out on so much learning opportunity if we put it into the real world and get to learn about all the previous considerations that I mentioned. What we really need to do is to make sure that we let our projects loose, run wild, and fail in all the unexpected ways that they must, because we will learn so much more from them while they're in the real world. In conclusion, the paths between ML researcher and ML engineer are more split than ever, and it's important to realize the need for data engineering, domain expertise, and deployment if you really want to stand out in the applied ML world today. So that being said, opportunities are still really incredible if you know where to look, right? So for example, my cousin is actually just starting college for data analysis and analytics. And if you're watching this, Colleen, I know your parents might not want you doing sound production, but if you care at all about data science in the first place, focus on putting those two together. And I promise you'll be in the best place possible when you come out of school. Anyway, to focus on these key points, I'm putting together some guidelines to follow for anyone really to make sure they're getting the experience they need to stand out. It's something that I'm currently putting into practice and battle testing myself. But once it's done, maybe in a week or so, I'm going to share it right here. So subscribe if you want. That said, I have much bigger plans for the channel and the Discord as a whole. I intend to build a whole community around this system, which will allow future and current machine learning engineers to stand out through applied end-to-end machine learning projects. More importantly, it should be domain agnostic, so you can apply machine learning to whatever field that's of interest to you, not just games, right? Before I end, I'd like to really give a quick shout out to the AI and DL group on Facebook. They have an amazing and active community that is centered around AI and DL with an awesome moderator, Arthur Chan, who and many helpful members who are actually paraphrased in today's video. All right, that's all I had. Let me know what you think down below. Agree or disagree, we're all here to learn, so I'm all ears. Thank you.